Okay, guys, today we're going to intro a new topic. We're going to talk about impulse. So there's a video. I was trying to figure out how to do this. I'm going to try to remake this when I have more time in the summer. But impulse, this is the idea. You should be on page 18 of your notes, page 18. So we're going to talk about impulse, what this actually means. So Newton's second law, it's already written down for you. Newton's second law is F net equals m times a. We already know that. But also we know that this little acceleration is the change in velocity over the change in time. So this is all stuff you should be writing down in your notes right now. So you can just draw a line like I have here, and then A equals delta V over delta T. So we're going to plug this in for A. That's what that basically means there. So I'm just going to show you how this equation is derived. So notice I plugged in my delta V over T in for A in this equation right here. So that's actually going to give me this mass times the change in velocity divided by the change in time, which is equal to acceleration. So now I want to get time. I want to move time to the other side. That's what it says in your notes. It looks a little bit different on your piece of paper, right? So then if I multiply both sides by T, right, these T's cancel. T divided by T is 1. And then what I do on one side in mathematics, I have to do on the other. So this is the equation for impulse. So force times time equals mass times the change in velocity. So you want to write this in your notes, probably on the right side of your page, right around here. You should be able to fit this in. But you really want to label what these are. You want to label what these things are in this, okay? So this part of the equation, this is what we're referring to when we talk about the impulse. All right, so that's what we're talking about. Force times time. And then momentum change is this side of the equation, the whole thing. So what's in red on the right, this is your momentum change, and this is what we refer to the impulse. So I'm going to explain this, the rest of this stuff in the other video, but there'll be another short Edpuzzle. I'll make it real short, kind of explaining this, because I was going to try to combine them in the one video, technical difficulties. So I'm going to show you that video next. So hopefully it'll make sense. I'm just going to cut down the video real short, add some voice notes to it. It'll be less than a minute. So there's two videos. The ball that didn't bounce is just like slammed. The balls are going at the same velocity. They're dropped from the same height, and they're going to have the exact same mass. Okay. So if I just look at the impulse, the left side of the equation here, of the ball that didn't bounce, and the ball that did bounce. Again, this will make more sense in the next video. It'll be really short. I'm going to chop it up to make it shorter for you. Okay. So the force is going to be much greater for the ball that didn't bounce because the momentum change is going to be much faster. But the time it's in contact, the time before it stops, before it comes into a complete stop, is going to be much shorter. That's why there's way more force on the ball. Again, the other ball is going to bounce more. It has the same velocity, dropped from the same height. It's going to have the same exact mass, but it's going to be made out of different material. Okay? So then it's going to have a much, I should have flipped that. I should have flipped my, yeah, I did actually. So notice on this one, guys, my force is way less, but my time, the amount of time it's in contact with it is going to be much greater. The force is way smaller, right? This F is the force. My time it's in contact with the surface is going to be greater. But notice these two arrows, if we added these together, notice these are equal in size and these are equal in size, but just opposites. Okay? That's just a visual representation of that. So if it doesn't make sense now, hopefully it will after I show you the next Edpuzzle video. Like I said, it's going to be real short. So both balls have the same impulse. So these two are the same impulse, but just they're flipped because they have the exact same mass and velocity. But since the time of contact, that's what's important, was different, they have different forces. That's what you got to write down there is the word forces. So this is an introduction into impulse. So I want you to watch this video. And yeah, there's one more Edpuzzle. It's pretty short. real short actually, just explaining the ball concept. Sorry I couldn't fit into one video.